Hello everyone, welcome back. Have you ever wondered how the efficiency of an engine would depend on the power output of the engine? We'll find out in this video. First, it seems obvious that if the engine does not put out any power, it will have efficiency 0. This means if you let run an engine on idle and you don't use it for anything, the only power that the engine will produce will be consumed to overcome friction inside of the engine and to run the oil pump and stuff like that. On the other hand, my car indicates me the fuel consumption, the instant fuel consumption and the average fuel consumption, and I found that accelerating quickly for a short period of time is better for fuel economy than accelerate slowly for a longer period of time. This would mean that the efficiency of the engine is higher if you use it at a power output near to its maximum power output than if you use it at a lower power output. What I want to do is verify this with my generator. I already calculated one value of efficiency at 1000 watt output power, and this was 13% for the overall generator, engine plus electrical generator. The electrical generator has an efficiency of about 50%, and so the engine has an efficiency of about 26%. You can see this in this video here, where I do all the testing and calculations. In this previous video I used a heater that could draw 1000 watt and 2000 watt, but this generator is not strong enough to hold 2000 watt for a long period of time, so I will need a device to get intermediate values for the power output. And this device is this voltage regulator. It's quite cheap and it can draw, you can put up to 4000 watt through it, and this will just put down the voltage. You can simply regulate the voltage by using this button from 0 to 220 volt. With this I will be able to adjust the power output of my generator and compare the efficiency values. So this is the formula for efficiency that I will use. It's simply power output divided by the energy that goes in form of gasoline, multiplied by time, running time. In my case, the energy input will be 17.1 megajoule of energy, because I'm using half a liter of gasoline. So last time I found about 13% of efficiency for a power output of about 1000 watt. So we'll see what happens if I take half of this power output. If I had constant efficiency, the engine would run 2 times the time that it ran with 1000 watt, and this means it would run about 1 hour. Alright, so everything is hooked up. I've got the heater, I've got the measurement clamp here, so this will measure the output current from my generator into that. And I will also be able to measure the output voltage. So we'll let this engine warm up and test that. So as you can see, I had to put a fan in front of this heater, because the fan inside the heater did not turn at high enough speed to cool the resistance down inside of it. So I've got half a liter of gasoline in here, and I will put that here. At a current output of 2.7 amps, the engine gives a power output of 615 watt, and the engine ran 43 minutes and 27 seconds. This is really far away from 1 hour. So this gives us an efficiency of 9.4%. Running the engine at 6.5 amps, it gives a power output of 1482 watt, and the engine ran about 26 minutes. This gives us an efficiency of 13.5%. This efficiency is a little bit higher than at 1000 watt. So it seems that increasing the power output increases the efficiency. Let's take some intermediate values. Running the engine at a current output of 3.5 amps gives us a power output of 798 watt. The engine ran about 39 minutes and 17 seconds. This gives us an efficiency of 11%. Running the engine at 4 amps gives us a power output of 912 watt, and the engine ran about 36 minutes and 22 seconds. That's an efficiency of 11.6%. Let's get really low. Running the engine at 1.1 amps gives us a power output of 250 watt. The engine ran about 42 minutes and 12 seconds. Wow, this is really bad. It's even less than running the engine at 615 watt. So this gives us an efficiency of 3.7%. That's really low. Just to verify if the engine is still running well, I will run this engine back at about 1000 watt to see if the efficiency is still the same. So running the engine at 4.65 amps gives us a wattage of 1028 watt. This time the engine ran about 31 minutes and 6 seconds. That's about 3.5 minutes less than before when I ran this engine at 1000 watt power output. This gives me an efficiency of 11.2%. I verified the oil. The oil level is a little bit too high. The oil is quite dark, so I will probably have to do an oil change. Let's take a look at the spark plug. The spark plug looks okay. So we'll let this engine cool down. Maybe it became too hot because it ran really fast at this low power output of 250 watt. So maybe it's due to that. Okay, so we are the next day. I ran this engine at 5.5 amps, and this gives us a power output of 1226 watt. The engine ran about 30 minutes and 26 seconds. This gives us a power output of 13.1%. We begin to see a shape in this curve, but we are missing one point. It's at the low end. We will run this engine at 2.1 amp. This time I've installed the spring of the regulator differently. I've installed it here instead of here, and this will make it more loose, so it will run slower. We will see if this will decrease fuel consumption. This gives us a power output of 478 watt. This time the engine ran 46 minutes and 11 seconds. That's the maximum running time that we ever had. This gives us an efficiency of 7.8%. This point fits right into the curve, so we're happy with that. So I think I've done enough measurements to confirm the shape of this curve, even if there are some uncertainties on my measurements of volume of gasoline, the measurements on time and on current output. But the points on this graph are confirming each other, I think. So we see that an engine giving a low output power will have less efficiency, and like above the half of its maximum power output, it will have a pretty good efficiency. So that's it. I think in the next video I will try to make the oil change and see if it does any difference, because some people claim that they feel it when their car needs an oil change, because the fuel consumption is increased. So we'll see if this could be true with this engine. So until then, I hope you all enjoyed, and I'll see you next time.